So today we're going to be doing trig identities. We're adding it in after 4.4. It was actually in 4.3 in our book, but we didn't talk about it then. And then we are going to be doing the chapter 4 MA homework number 8, practice test 4.1 to 4.4, part 1 today in class. So again, in terms of what we've covered so far, let me just get this lamp on. 4.1 radian and degree measure. Again, all this is from our pre-calculus book. 4.2 unit circle, 4.3 right triangle, 4.4 trig functions of any angle, and then Pythagorean trig identities or trig identities. My main concern is that we get the Pythagorean ones in. Okay, so we're going to take notes on that, and then we'll work on the practice test part 1 together. Okay, so I'm just going to title this trig identities because I am going to be listing more than just the Pythagorean. And the first ones I'm going to talk about, we've already have seen before, but I'm just going to mention them here. Quotient identities. So our quotient identities that I'm going to write for us, I'm going to write tan theta is equal to sine theta over cosine theta. And its reciprocal, cotangent theta, then is equal to cosine theta over sine theta. Next, I'm going to be talking about our reciprocal functions. So reciprocal, not functions, sorry, reciprocal identities. Okay, and we've seen these, but I'm going to write them out again. So we have all of these relationships here. So sine theta is equal to 1 over cosecant theta. So remember, I always say S doesn't go with S and C doesn't go with C, because you have sine and cosine, which are S and C's, and you have cosecant and secant. You also have cotangent, but hopefully you know cotangent and tangent are going to match together. So those are both S and C's, and so the way I keep it in my mind, because they're all very close sounding, S doesn't go with S, so sine, since this is S, its reciprocal is the cosecant. And that means that I can write my cosecant in terms of my sine. So let me do that. Let me zoom out. Okay, so cosecant theta equals 1 over sine theta. And I'm going to also do my cosine theta. And again, C doesn't go with C, so this is going to be my S secant theta. And that means secant theta can be written as 1 over cosine theta. Now, cotangent, tangent, those are reciprocal, so tangent theta is equal to 1 over cotangent theta. And cotangent theta is equal to 1 over tangent theta. So these are quotient identities. Quotient means division, so you see how we can write tangent and cotangent in terms of dividing sines and cosines. And over here, this one is our reciprocal identity. So again, reciprocal functions, because these are reciprocals. Now, the next thing I'm going to talk about is I'm going to introduce where we get the Pythagorean identities I'm going to talk about. I'm going to start with a unit circle. Okay, I'm just going to draw a unit circle. And so I'm just going to label it unit circle so you know. So unit circle, again, has a radius of 1. So if I draw to here, this has a radius of 1. This is going to be some point x comma y. And what happens is if I draw straight down to the x-axis, this is going to be x. This right here is going to be our y. Okay? So let me just kind of redraw that out here so we can see it a little bit better. Okay, so this is 1, this is x, this is y. So if I'm using Pythagorean theorem, I know that x squared, here's my right angle, plus y squared equals 1 squared. And so x squared plus y squared equals 1 on our unit circle. Now, remember that these are actually coordinates. These coordinates really are your sine and your cosine. So this is really cosine theta, comma, sine theta. Okay? Cosine theta, comma, sine theta. So I'll write it here. Let me get my red pen. So remember, x is equal to our cosine theta. On a unit circle, y is equal to our sine theta. So this is going to be cosine squared theta. This is going to, and notice where I put the square. This is cosine times cosine, but we would go cosine squared theta plus sine squared theta, because we're squaring the actual value of our cosine. We don't want it here with our angle. We're not squaring our angle. Equals 1. This is going to be our Pythagorean identity. So I am going to write Pythagorean trig identities. And I'm saying identities because we're actually going to have 3 of these. Okay. The first one is this one. I usually think of it as sine squared theta plus cosine squared theta equals 1. But it doesn't matter if you start with your cosine or your sine. Addition is commutative. Okay. Now, this is the one I memorized. You need to know this one. The rest of these you can always derive. Okay. And so I'm going to derive them. So I'm going to take sine squared theta. But here I'm going to do some math. Plus cosine squared theta equals 1. And I'm going to divide everything here by sine squared theta. And you'll notice what happens when I do that. Sine squared theta over sine squared theta becomes 1, so I get a 1. Cosine over sine is one of these quotient identities, okay? It's this quotient identity. So it's going to be cotangent. So this is going to be cotangent squared theta. And then 1 over sine squared, 1 over sine, remember, is cosecant. So we just ended up with another Pythagorean trig identity. So I'm going to write that one. 1 plus cotangent squared theta equals cosecant squared theta. And again, I don't memorize this. I can always derive it just by dividing by sines. And then the next time I'm going to divide by cosine. So we're going to do this one more time to get our third one. So if I take sine squared theta plus cosine squared theta equal 1, I'm just going to draw a line, so I'm separating these. And so I'm separating these. And I'm going to divide them, instead of by sine, this time I'm going to divide them by cosine squared. You'll definitely see this in integrated 3, these relationships. So sine over cosine is tangent. So this is tangent squared theta. This is going to become 1. And 1 over cosine, that's secant, so this is going to be secant squared theta. So tangent squared theta plus 1 equals secant squared theta. And those are your Pythagorean trig identities. Now, in some of the assignments, they have asked us to find maybe a cotangent given a cosecant, or maybe a tangent given a secant or something like that. And they asked us to use trig identities. At that time, we didn't really know what they were. We were drawing it out as a triangle. So I'm going to run through a problem. I'm going to do it the way we were doing it, and then I'm going to do it using these, okay? So that you guys see how to do both of those. So in this example, let's say we have if cotangent theta is equal to 5 over 12, find cosecant theta. I'm just going to draw a little separation here. Okay. Find cosecant cosecant theta using trig identities. So I'm going to do trig identities here in a second. I'm going to just run through how we have been doing it, because both of these methods work. But if they ask for trig identities, it's going to be what I'm going to do here. So cotangent. Now cotangent is actually positive in 2 quadrants. This quadrant 1 and this quadrant 3. When we were these problems were the section that this was from, we were only working in quadrant 1. So we're going to just do this in quadrant 1. Okay, and this is going to be my theta. And cotangent is the reciprocal of tangent. Okay, remember tangent is opposite over adjacent. So sometimes it helps me to think of it in the other form. So tangent is equal to 12 over 5 because it's going to be the flip. So now that sometimes helps me set this up. Opposite is 12, adjacent is 5. And then I can use Pythagorean theorem, 5 squared plus 12 squared, to figure out this. This actually is one of the nice triples. This is 5, 12, 13. So I'm going to save us the time and just tell us it is a 13. But again, I use Pythagorean. Now they want us to find cosecant. Well, cosecant is the reciprocal of sine. So let me first find my sine, and then I can take the reciprocal of it. So sine is opposite over hypotenuse, which is 12 over 13. So that is going to mean that our cosecant is going to be the reciprocal of this, which is 13 over 12. And that would be your answer. That's how we have been doing it. Now I'm going to show us how to do it using the trig identities. Now you'll notice we have cotangents and cosecants. So you want to look and see, well, do we have any trig identities dealing with those? Right here. 1 plus cotangent squared theta equals cosecant squared theta. So you see I've got cotangents, cosecants. Okay, so I'm going to use that one. Let me just write it here for us. So 1 plus cotangent squared theta equals cosecant squared theta. And 1 plus, now my cotangent is 5/12. So I'm going to take my cotangent, which is 5/12, and I'm going to square it. Equals cosecant squared theta. So now, let me just write this out first. This is going to be 25 over 144. So let me write my 1 in terms of 1/44. So this is going to be 144 over 144, that's 1, equals cosecant squared theta. So now when I add these together, I get 169 over 144 equals cosecant squared theta. Now, hopefully you'll recognize 169 is a perfect square. The square root of it is 13. 144, square root of it is 12. So I don't want cosecant squared. I want cosecant. So I'm going to take my cosecant squared. I'm going to square root that, which gives me cosecant. And I'm going to square root that, which gives me 13 over 12. And that's the same answer I got in the other problem. So these are both methods. This I'm using the idea of a right triangle and Pythagorean, okay? Here I'm using the Pythagorean trig identities. So now I'm going to switch over to the practice test, and we're going to run through that. Okay, so again, I put this with your classwork. You want to get it from classwork and not from the stream, because on the stream you can't edit. You can print out, but you can't edit. So again, this is chapter 4, math analysis homework, number 8. This is 4.1 to 4.4, practice test part 1. And for homework, we're going to do practice test part 2. Okay. Okay, so I'm going to run through these questions with you guys. So on these first ones, whenever you're going more than once around the unit circle, okay, whether it's in radians or degrees, if it's in degrees, I would just keep taking 360 until I get onto it. Now you can keep taking 2 pi off of these until you get onto it, but this is what I do when I think about these problems. If I have a pi, any pi, what's going to happen is, as I go around the unit circle, this is going to be 1 pi, 2 pi, 3 pi, 4 pi. What you'll notice is this is all my odd. This is all my even. So I'm just going to write here. So this is going to be, let me just get, this is going to always be my odd pi. So if they said 99 pi, don't count around. This would be 99 pi. If they said 108 pi, this side would be 108 pi. This is always your even pi, okay? So since this is 7 pi, it's going to be here. So let me just put that in this color. And so this is going to be my 7 pi, and this is going to be -1 comma 0. And they wanted us to actually figure out what side this is. So if I was drawing the terminal side, it would be here. Now, this is not a quadrant, okay? In between 0 and pi halves, that's quadrant 1. In between pi halves and pi, that's quadrant 2. This is on an axis, okay? It's on the x-axis. Now, don't tell me, oh, it's between 2 and 3. Tell me it's on the x-axis, but be specific. Is it on this side or on this side? Where am I? So you're going to say the negative x-axis, or if it was on the y-axis, you're going to say it's on the positive or the negative. Now, on one like this, again, you could sit here and count your thirds all the way around, but this is what I do. I want to figure out how many whole pies it is, because that will tell me if I'm here or here, and then I can count the remainder from there, okay? Again, you can subtract 2 pi off until you get here, but this is how I think about it, especially if it's really, really big problem. So this is what I do. I'm going to take, let me do it in black. I'm going to take 3 into 23. It goes in 7 times evenly, okay, with a remainder of 2. So what that means is I'm going to go a whole 7 pi, which is going to put me over here to this side, and then I have 2/3 or 2 pi thirds more to go. Okay, so this is how I'm thinking, how I think about it. So I'm going to draw my 7 pi in one color, and I'm going to do my 2 pi thirds in the other. Now, I'm going 7 pi, so I'm going around and around and around, but eventually I'm going to end up coming to here, and that would be my 7 pi. And then I need to do the remainder of it, which is going to be this 2 pi thirds. So this would be 1 pi third. This is going to be 2 pi thirds. So then I'm going to take the other 2 pi thirds and end up here. So this is me going 2 pi thirds beyond. So I went 7, and then I went 2/3 pi. And so I end up over here. Let me just put a dot so we can see it. I end up right here. That's where I'm going to end up. And that is going to be in quadrant 4. Okay. Now, the next one, these ones were changing from radians to degrees or degrees to radians. This is in radians, it's in pi. And if you remember from integrated 1, that we can multiply by what we call the big one, 180 degrees and pi are the same. So when we were doing these, you want to cancel out units. In this case, we want to cancel out pi's. So I want the pi on bottom, and I'm going to have the 180 degrees on top, okay? And so you'll notice that my pi's are going to cancel out because I have a pi on top and I have a pi on bottom. And then I can just do that math, okay? So now I'm going to take, actually I'm going to do it in a fraction form. So I did alpha y equal. I'm going to hit number 1, and then I'm going to go 17 times 180 over 11. It gives me that. Now, if you want it as a fraction, if you hit the math button, you can also do it under second alpha and y equal for the fractions, but if you hit the math button, number 2 is decimal, and it will change it for you. So it's 278.18 repeating degrees. So 278.18 repeating degrees. Now, this next one says 16. It does not have a degree because it is not in degrees. This is in radians. So remember, a radian, 1 radian is 1 radius length around your circle. So we would take 16 of our radii around our circle. That's really what's happening, okay? So again, this is not in degrees. So I am going to multiply it again by the 180 over pi because I want to change it into degrees. So I need that degree on top, and my pi is going to be on bottom. Now this I'm just going to put into my calculator. Okay. So 16 times alpha y equal, and I get 180 over pi. And I get 916.73 degrees, about 916.73 degrees. I'm rounding. And that is your answer. So this one, we're going to change it from degree to radian, and they want exact value. So when they say exact value, you want to still have your pi. So you don't want to be putting your pi in like we did here and giving me a decimal. You want to have your pi still in your answer. So I'm going to take negative 380 degrees, and I'm going to times it by the same relationship, pi and 180 or 180 over pi. I want to get rid of my degrees, so my degrees need to be on bottom because I want to be changing my answer into pi. So that's going to be on top, okay? Now, when I'm doing this, you might see that the zeros are going to cancel out because I really can take a 10 out and then I can reduce that. But you can also put it in your calculator, and you don't want to put in the pi. So again, I'm going to do alpha y equal, and that gives me the fractions. I'm going to hit number 1, and I'm going to do negative 380 over 180, and it will reduce it for me. Notice I did not put in the pi. I'm going to stick the pi with it here. So it's negative 19 pi ninths. That's what they mean by exact. You should not be giving me a decimal here. Okay, next section. So these ones, we want to draw the angle in the right quadrant. You want to give me the, so I want really the terminal sides, what I want to see in the picture. I want the coordinates of the point where that terminal side ends. And then you need to answer the question. You need to pay attention that this is the question. What is the secant of pi? So pi is right here. So I'm going to come here. I'm not going to draw a triangle at all. Sometimes some people try and draw triangles. There's no triangle to draw here because we always draw to the x-axis, and I'm on the x-axis. And the coordinates of this point, negative 1, 0. Okay, I want to see that. Now, secant. Remember, secant is the reciprocal of cosine. Okay, so cosine pi would have been negative 1. I want the secant of pi. So I'm going to take negative 1 and I'm going to take the reciprocal of it. Well, negative 1's reciprocal is -1. So secant pi equals -1, and that is your answer. But again, I want to see the terminal side and I want to see the coordinates. Okay. Cotangent of 120. Okay, so 120 degrees, it's going to be ending here at this point. Sometimes it might be helpful to draw your triangle for yourself to see it. That's the triangle. Notice I drew it to the x-axis, not to the y-axis. It's always how far above the x-axis or how far below the x-axis. So this is short, comma, long. Remember, whenever I say short, 1/2. Every time I say long, √3/2. And I'm going negative, comma, positive. So I'm just going to zoom in so I can write this. This is going to be a -1/2 because that was my short, comma, long, positive √3/2. Okay, so again, give me the coordinates. And then I want the cotangent. Now, tangent, remember, is y over x, or sine over cosine, but y over x. So cotangent is going to be x over y. So I'm going to be taking -1/2 over √3/2. Now I'm going to do the math for us, but we've done enough of these that some of us might already know what the answer is going to be. So I'm going to take -1/2 over √3/2. We don't like fractions divided by fractions in this form. So what I'm going to do is when I take a fraction divided by a fraction, I take that fraction and multiply it by the reciprocal of what I'm dividing by. So this thing down here, that's the one I'm flipping, okay? Not both of them, just that one. So this is going to be, whoops, highlighter, sorry. This is going to be -1/2 times 2 over √3. And you'll notice, and some of us aren't paying attention to this, but the 2 and the 2 cancel out. And I end up with a -1 over √3. But remember, we need to rationalize. So I'm going to be multiplying top and bottom, because we don't like radicals in our denominator, by √3 on top and on bottom. So when I do that, my final answer, my cotangent of 120 is going to be √3, negative, because I had a negative here, over, and √3 times √3 is 3. And that's my answer. Okay, now again, we see this often. So some of us, for the minute we have the -1/2 on top and the √3/2 on bottom, some of us know it's going to end up being this one. Because your √3 is going to be on the bottom, you're going to have to rationalize. Okay. So this is negative, so we have to pay attention to this being negative. It's a -2 pi thirds. So -2 pi thirds would be coming this way, so I end up here. And again, I draw it to my x-axis. I'm always starting at the origin. This is going to be short, comma, long, negative, comma, negative. So it's going to be a -1/2, negative √3/2. Again, short, long. And cosecant is the reciprocal of sine. So let me just jot down the sine of this. It's not what they want, but I'm going to look at it. The sine of this is -√3 over 2. So I want the reciprocal, let's move it over, it keeps on popping back, of that, which would be 2 negative, the whole fraction is negative, 2 over √3. Again, I need to rationalize. I'm going to multiply the top and bottom by √3. And when I do that, my answer, I'm going to get cosecant of, let me get my cosecant in here, cosecant of -2 pi thirds is equal to negative and 2 √3 on top, and √3 times √3 is 3. And that's your answer. Okay, and again, a lot of us have been doing a lot of this rationalizing, so we can kind of do it in our heads. That's great. But I do want to see the coordinates of that. Okay, now next one, cosine. of negative 43 pi 6. So again, this is one that's definitely going around the unit circle a lot of times. So let me just figure out where I am. So I'm going to take 6 into 43 just to kind of see if I'm at an even or an odd pi evenly, and then go from there. So this goes in 7 times, which is 42. We've got a lot of 7s today. Bring down the 1. So this means we're going to have 7 pi. We're going to go 7 pi, which means I'm going to go to here. And actually it's negative, but whether I'm going positive or negative, my 7 pi will be here, because this is always my odd. This is always my even. But the remainder of this, that pi 1, pi 6, is going to be going this direction. So again, just let me color code. 7 pi, again, yes, I went around many times, but as I'm coming around, I end up here at, I'm just going to write the 7 pi here, okay? I end up here at 7 pi, and then I'm going to go pi 6. So pi 6 more is right here. That's me going an extra pi 6. So I went 7 and 1/6 pi, okay? And I ended up at this point here, and that point is long, comma, short, long, and it's negative, comma, short, positive, because of the quadrant I'm in. So now I want cosine. Well, cosine is your y, your x. And that's going to be our answer. So let me just write it out. Okay, so the cosine of negative 43 pi 6 is negative √3/2. Okay, again, you want to make sure you're giving me the answer that they're looking for, not just drawing the angle in, not just giving me the coordinates, or not just giving me the answer. I want to see the coordinates. Okay, next page. Okay, so find the exact value of the other trigonometric functions if cosine theta is negative 7/25 and theta is in quadrant 2. Okay, now they gave us what quadrant we're in. Let's say they didn't. I actually have 2 quadrants where my cosine is negative. My cosine is negative in quadrant 2 and in quadrant 3. So I could have possibly had 2 answers, but they are telling us it's in quadrant 2. I, a lot of times, want to just focus myself, so I like to just shade so I don't forget where in the world I am. Okay, that's where I am. Now I'm going to draw my right triangle. So when I draw my right triangle, I'm going to go out to a point. Let me draw that better. Okay, so I'm going to go out to a point, and I can come down because I want to see this triangle here. And let me just draw my theta in. This is where my theta ends. This is my right angle. And we know that our cosine is a negative 7/25. Now, first off, this is going to be a negative. This is going to be a positive because of the quadrant I'm in. Your hypotenuse will never, ever be negative. I don't care what quadrant you're in. You'll only have negatives on a possible leg, one of the legs, not your hypotenuse. Now, in this case, it's negative 7/25, which is adjacent. And I am going negative direction, so that's my negative. And then here's my hypotenuse. Now, I'm going to do Pythagorean theorem to work this out, okay? And I'm just going to do it real quick in the calculator. So my hypotenuse is 25, so I'm going to take 25 squared, which is 625. I'm going to minus, and this is where you got to be careful, 49 might be the easier way to do it, but if you're not going to do that, it's a negative 7 squared, and I get a 576. Now 576 doesn't look like a nice number, but if I take the square root of it, and it would have been easier probably just to raise it to the 0.5, because that's usually what I do, you get a 24. Let me just put in a different color because this was not given to me. This is a 24. Positive because I'm going up. So now sine is opposite over hypotenuse, and opposite over hypotenuse is 24/25. And now cotangent is the reciprocal of tan. So I'm just going to write tan here because, again, sometimes that helps me. Tan would be opposite over adjacent. That would be 24 over -7, which means this is going to be the reciprocal of that, -7 over 24. Okay, so those are our answers. Now, in the next ones, they are not telling us what quadrant it is. So when we see that this sign's negative, again, that's in two different quadrants. They want us to figure out the two angles. In radians, they sit it here, but anytime they write this, this is radians. If they go from 0 to 360 degrees, then they want it in degrees. So for this, I want to figure out where sine is negative first off. So I like to shade where my sine is negative. Okay, well, my sine is negative down in both of these quadrants. So I'm down here. This is where I am. So my two angles that I'm going to be giving, one will be in this quadrant, one will be in this quadrant. And then you want to think about where my sine is a -1/2. That's my short. Okay, and remember, sine is my y. So this would be short comma long, so that's not it. This one is √2/2 over √2/2, right? Always that middle one. This one here is going to be long comma short. And over here, it would be in the same spot, long comma short. So these 2 points, that's the two angles that would give me a -1/2 for the sine of it. Now, where am I? So this is pi6. This would be like a pi4. This would be a pi3. So when I do this, I always convert my pi into whatever I'm dealing with. So if this is 6, this would be 6 pi6. So that means this answer is 1 beyond that, so 7 pi6. That's going to be one answer. That's where this is. Now, if this is 6 pi6, then all the way around would be 12 pi6. That's really 2 pi. So this is one short, so this is 11 pi. Let me write it better. 11 pi6. And those are my two answers. Now, if they had asked us in degrees, and they said, oh, from 0 to 360, this is 180, this would have been 210. This is 360, this would have been 300. And those would have been my two answers. Okay, now this one here, secant. I don't think as easily in terms of the reciprocals. I think better in terms of my sine, cosine, tangent. So I'm going to change this to the cosine in this case, because that's the reciprocal. So if this is my secant, then the cosine of that same angle, because really we care about the angle, okay? So that same angle would give me a cosine. That's the reciprocal of this. So it's going to be 1 over the negative square root of 2. I need to rationalize. So I'm going to multiply top and bottom by √2. And so when I do, I get a 2. Hold on a second. Let me get my negative in here. Cancel, didn't want to clear everything. I get a negative √2 over 2. Again, I'm multiplying this by √2, multiplying this by √2. You'll recognize your cosine in this form better than in this form. And where is my cosine negative? So my cosine is negative in these two quadrants here. So this is where my two answers, my two angles will be. Now, my coordinates where I have a √2/2, those are your 45s or your pi4s. So that's going to be here, and that's going to be here. Those are going to be the two spots. Now, again, this, if I'm thinking about force, this would be 4 pi force. That's really what pi is. 4 over 4 is 1. So that means that this one up here, let me zoom in a little bit more. This one here would be 3 pi force. And then this one, which is 1 beyond, would be 5 pi force. Okay, and last but not least. So when I'm dealing with a root 3 or a tangent, okay, you want to decide if your root 3 should be on top or your root 3 half should be on bottom. So remember, tangent is y over x. So I'm just going to write this out and then I'm going to erase it here in a sec, but you want to figure out, hey, should it be the root 3 halves over 1/2, where this is your y and this is your x, or should it be 1/2 over root 3 halves? Well, after we've done enough of these, what's going to happen here is I'm going to multiply this by 2 over 1, and my 2's are going to cancel and be left with the root 3. In this case, I'm going to multiply this by 2 over root 3, and my 2's are going to cancel, and I'm going to get a 1 over root 3, which is root 3 over 3. So it's going to be this one, right? That's the one. Now also, where is your tangent positive? Your tangent's positive where your x and your y are the same coordinates. So where you have a positive positive or where you have a negative negative, because again, it's y divided by x. So this is positive divided by positive, which is positive, negative divided by positive, positive. If the coordinates were different, you would get different signs, you would get a negative. So that's going to push me into quadrant 1 and quadrant 3. And then again, I want my y to be my root 3 halves. So my y is a root 3 halves, short comma, long. When I say root 3 halves, negative and a negative, but where the y coordinates are root 3 halves, and short comma, long. Now these are 6. This is actually pi 6, so that's one answer. And again, sometimes it helps me. Pi would really be 6 pi 6, which means this is 7 pi 6. And those are my 2 answers. And that's part 1 of the practice test.